Okay, we're going to do a little gravitation problem. Okay. And the gravitation problem is this one. How far from the Earth must a body be along the line towards the sun so that the sun's gravitational pull balances the Earth's gravitational pull? So the problem is this. So we have here our sun. That's our sun right there. And then we have the Earth over here. So this would be the sun. And let's put this is be the mass of the sun. And we know that all the mass is concentrated at the center of the sphere. So it's going to be like a mass point. And then we have over here the mass of the Earth right here. And we're going to have a little particle right here, somewhere between the sun and the Earth. And then we're going to have a distance that comes from here to here. And another distance that comes from the particle to the Earth. So we have this distance. So we know that the distance from the sun to the Earth is 9.3 times 10 to the 7 miles in total. That's the distance from the sun. This would be the distance from the sun to the Earth. And we know that the mass of the sun is 3.24 times 10 to the 5 masses of the Earth. That's what we know. And we're looking for x, which is the distance. X would be the distance from the particle of mass m to the Earth. So that's what we're looking for. The distance, this one, we're looking for this guy right here. What is the distance from the particle? The particle is this one right here. It has a little mass m. Its little m is the mass of the particle. And this distance over here is going to be 9.3 times 10 to the 7 miles minus x. That's the distance from the center of the sun to the center of the particle. And we want to know how far from the Earth must the body be along the line towards the sun so that the sun's gravitational pull balances the Earth's gravitational pull. That means that this force, which is going to be the force of gravity by the sun, needs to have the same magnitude as this one over here. And this is the force of gravity by the Earth. And these two forces are going to act on the particle that has mass little m. And yeah, they're going to have the same magnitude. They're going to balance each other. And let's find that equation. So the force of gravity of the sun is going to be equal to the force of gravity of the Earth right there. So that's going to be, what is that going to be? That's going to be G, that's constant of gravitation, of universal gravitation, mass of the sun, mass of little particle over the distance, which is 9.3 times 10 to the 7 miles minus x, and this has to be to the square, and that's going to be equal to G, mass of the Earth, mass of the little particle over x to the square. And we can flip these guys here, or what you can do here is, well, G is going to cancel with G, M is going to cancel with M, and then we're going to have x to the square, mass of the sun over mass of the Earth is going to be equal to 9.3 times 10 to the 7 miles minus x to the square. And now we square root everybody, get the square root of these two guys. So this is going to be x mass of the sun over mass of the earth, square root of this is equal to 9.3 times 10 to the 7 miles minus x. So we're going to send this the x over here. So it's going to be x square root of mass of the sun over mass of the earth plus x is going to be equal to 9.3 times 10 to the 7 miles. So it's going to be x, and then we're going to factorize this here inside. The mass of the sun is 3.24 times 10 to the 5 masses of the earth, divide by the mass of the earth, and we still got to get the square root of all this here, plus 1 is going to give, so this is going to cancel with this one right here, is going to be equal to 9.3 times 10 to the 7 miles. And this is going to be, okay, if you do this math right here inside the brackets, I'll do it right here. It's going to be, if you do this, x is going to be equal to 9.3 times 10 to the 7 miles, divided by 570. And that's going to throw you, 1.63 times 10 to the 5 miles. This is going to be miles. Okay, miles. And this would be your answer right here. It's 1.63 times 10 to the 5 miles. So you got your x over here. The distance here is going to be 1.63 times 10 to the 5 miles. And that's the answer from the book Holiday and Resnick. There you go. So that's the distance from the little particle that has mass little m to the earth. So you do have another problem there. Thank you. Bye.